And here is the main board-ish thing. So we've got our that out of the way. We've got our Raspberry Pi Model B Revision 2. Connects over to this board with this ribbon cable. Power, everything that goes out of this box connects right here. So basically all this is doing is this chip here is a quad N MOSFET. I'm only using one of them at the moment, and that's to level shift the output to the power supply. This down here was I was trying to get the Raspberry Pi to be a DMX slave, but as it turns out, setting the serial baud rate to 250K is non-trivial. Plus, you can't detect break conditions easily from Linux anyway. There's nothing about the Raspberry Pi hardware that makes it difficult. It's just that Linux generally doesn't like you to do that. So we have ground plus 5 volts, and then there's two pairs of I2C. So since the Raspberry Pi is at 3.3 volt and the ATmega 328s are all 5 volt, at first I was just going to pull the I2C bus up to 3.3 volts and have that, and just cheat a little bit there. But as it turns up, the huge amount of capacitance on the bus and the it's way beyond what I2C was designed for, so I ended up getting one of these from Adafruit, one of these I2C friendly level shifters, and I added my own pull-up resistors because the built-in ones are kind of weak. And then here are a set of jumpers to say which to connect the I2C outputs to. So the Raspberry Pi has two I2C buses, but only one of them is on the GPIO pin. So I ended up, the other one's on the camera header. So at first I was like, oh well, let's just solder directly to the Raspberry Pi, and well, there are people, I don't have any magnification, so that's kind of hard. So I ended up just buying this flat flex cable, slashing it to pieces, and soldering some wire onto it. So that actually works okay. The issue is the Linux driver for this system on a chip really doesn't like it when you try to use both I2C buses at the same time. When you're transmitting on one, the other one receives garbage data, and if you transmit on both of them, it ends up kernel panicking sometimes. Although it's kind of hard to capture because I don't have a serial monitor running, which is kind of what I'm going to use this for next. I'm going to try and figure out some way to do a serial monitor because it's really annoying. So yeah, this ended up being kind of a pointless waste of time. Hopefully, now once they actually want the camera to work, hopefully they'll actually patch the I2C bugs. I've reported them, but they have trouble reproducing them. I'm not sure if it's actually the Raspberry Pi itself or if it's the power or what's going on, but when you try to transmit on both I2C buses, after a while it kernel panics, or it just freezes up. So I'm powering it from your standard ATX power supply, which I've modified quite a bit. I'm only using the 5 volt rail. The 5 volt and the 5 volt standby. The Raspberry Pi is running off the 5 volt standby, and the LED board itself is running off the regular 5 volt rail. You see as I mentioned, the downside of using 5 volts as our main power supply is that can't really go over distance with it without it dropping, especially because ATX power supply at the output is 5.00 volts. So, you know, with a super thick cable that cost way too much money, we managed to get the resistance down low enough so that in the worst case it's down to 4.85, which is still good enough for our boards to run off of for the most part. Some of them not so much. But some of them will act a little weird if they have all the LEDs on at full brightness, but that's a rare circumstance, you know. So not really all that concerned. Plus, we need to turn the brightness down anyway because we're going over spec on the chips. Yeah. So here's the case I made for the Raspberry Pi. So lesson learned the hard way. You can't use regular drill bits to drill into plastic. You end up with really irregular holes. But thankfully, this didn't end up coming out too bad.